Welcome to Ask and Learn.
In this question, we are asked to show that the set of strings of lowercase English letters are not well found nor dense under lexicographic order. So the one that compare when we have string of words, we compare each position, and the first position that don't agree, we take the character that come first to be lower. So between these two words, this will be lower, this will be higher. Okay, and so we have to prove it's not well found nor dense. So we have to disprove two things. Well found is a property that there's no infinite decreasing sequence. So we are going to find one, right, as a counterexample. So consider a sequence starting with B. Next is AB. Next is AAB. And so on. So we just keep adding letter A at the front of the previous word, right? We can do something like this is AX n minus 1. And x1 is B. Yeah, we can define it like this. And you can see that it is strictly decreasing, right? B will be greater than AB, which in turn greater than AAB, and so on. But we don't have to stop. We can keep going forever. So this is an infinite decreasing sequence, and they are all inside the set. So the set is not well found. Okay, this is counterexample. Next, dense is a property that any two distinct elements, call it x and y, we can find another element set that can be inserted in between them. So for any two element x and y that's not equal, there will be set in between them, and set is obviously not one of them as well. So we can keep adding element in the middle. Now, to show that the set is not dense, so we have to find some pair of elements x and y such that there is no other element in between them, and you can find it easily. For example, A and AA. Here, obviously A is lower than AA, right? But there can be nothing else in between them. So suppose we have AX and AA here. So if there is X in between, and we want X to be strictly lower than AA, that means we have to change something. And in lexicographic order, when we change, we start from the digit to the right? We have to lower it, and this is already at A, so by lowering it, it means cutting it out. But then we are left with A, which is already the other side. So we can have X in between that is not A, that is less than AA. So this can happen. And so we have found a pair that break this condition of denseness. So yeah, that is it. We have shown both properties. That is not true for this set. Thank you.